right, so today we're going to be discussing the the 10th problem on the team round on the sixth high school contest, where we have a triangle A0, B0, C0, with A0 at the origin and C0 at 2, 0, and B0 is in the first quadrant. We basically will now define a sequence of points A1, A2, A3, all the way up to infinity, which we can see the first few examples here in such a way that each segment is going to be perpendicular to the previous one, and the slope of the first one is square root 3/5. So this is essentially what it could look like. And now what it's asking us to do is find the sum of the segments. So in particular, x0 is the length of the segment a0, a1, plus this distance from a1 to a2, then a2 to a3, and so on. Right? So we want to find the total length of this zigzag in the middle, basically. And it's expressed in this certain form. And so essentially, the key idea is how do we deal with this sum of these infinite number of segments, right? And well, I guess one observation that you can make is that since each segment is perpendicular to the one before and after it, they can essentially come in like two sets of segments, right? In such that, for example, A0, A1 is going to be parallel to A2, A3 is parallel to A4, A5, because they're all perpendicular to the other one. And similarly, A1, A2 is parallel to A3, A4, parallel to A5, A6, and so on, right? So I guess that motivates our idea of what if we stuck them all end to end, right? So for example, what if we moved A2, A3 to A1, B1, and then we moved A4, A5 to where B1, B3. And so if that happens, what we can essentially end up doing is these segments that are parallel to A0, A1, they will eventually total out to this A0 to X, where X is the perpendicular from C0 to this line, right? And similarly, if we do the same thing with like A1, A2, A3, A4, A1, A2, we can move to X, B2, A3, A4, we can move to B2, B4, because we essentially are just moving things within rectangles, right? And rectangles have opposite sides are equal. So we can just repeatedly do this. And as we approach infinity, we can essentially get that the sum of these infinite segments total out to A0 to X and then X to C0. So, well, what does this mean for us? This means that after moving some stuff around, after moving around all of these segments, what we've reduced it to is instead of having to deal with the infinite number of segments, we now only have to deal with these two segments, in particular A0x plus XC0, right? And so that motivates us to look at what can we figure out about this triangle A0XC0, right? Well, I guess a first thing that we can notice is that it's a right triangle, right? Because when we move the stuff around, the stuff started out perpendicular. For example, like when we had A1, A2, and we move it here, XB2 is still going to be like perpendicular to A0X, right? So as we move this stuff around, the right angles are still preserved. So it stays a right triangle. And well, what else do we know? We also know that the last, like one important piece of information that we haven't used yet is we know the slope of A0X, right? And well, what does slope mean in this instance, right? Well, slope basically can tell us the angle it makes with the x-axis, right? But the x-axis in this instance is just A0, C0. So we can see that this is equivalent to saying that the tangent of this angle of the right triangle is equal to √3/5, right? And well, now this is basically, we now know enough about the triangle to basically tell us everything about it, because theta is something that we can figure out, and A0, C0 is the hypotenuse, which we're told is 2. So essentially, what we've reduced it to is we just have to evaluate A0, C0 times sine theta plus A0, C0 times cosine theta. This we can do because we already have basically a way to figure out theta. So we know tangent of theta. So if we use some trig identities, we can eventually get that sine of theta is √3/2 √7, and cosine theta is 5/2 √7. And well, if we eventually just put everything all in one place and like rationalize denominator and all that, we can get that our total sum of all of our segments is root 21 plus 5 root 7 all over 7. And so if we go back to what we originally wanted, we wanted a plus b plus c plus d, right? So that's 21 plus 5 plus 7 plus 7, right? And that ends up giving our final answer, which is 40. And so we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.